What you just saw was a piece of music composed by an 11-year-old using Codetta, the software featured in this presentation. The focus of this talk, however, is on the methodology that was used to refine Codetta's interface, so hopefully what I talk about today will be applicable to other child-computer interaction research. An objective for this presentation is to demonstrate Codetta so that you get a feel for the interaction. Hopefully this will complement the paper, making descriptions clearer for how parts of the interface were improved using the described method. Before starting, I would like to thank the general co-chairs Sally Ann Lamberti and the paper co-chairs Francisca and Romain for inviting me. Codetta began with Scratch, which is a widely successful block-based platform used to teach programming in schools today. The blocks represent different commands, which move around sprites on the stage. As you can imagine, children experiment quickly using block-based tools. The results of their tinkering are realised rapidly. As children play with the software, they unwittingly accelerate their problem-solving and computational thinking skills, and it is this intrinsically motivated, self-led, passive style of learning which has made block-based programming successful. Where other block-based tools for music have often focused on supporting computational thinking, Codetta focused directly on supporting children in music composition. Theoretically, children could learn to compose through exploration, just like in Scratch. This is opposed to traditional music pedagogies, where children would have to learn rhythms first, then engage with singing, and so on. So firstly, a start block must be added. As is the same in other block-based programs, you drag blocks from a toolbox into a workspace. So I can tell this is a start block because it has a curved left edge, which signifies to the user that no blocks can be connected to the left of it. So secondly, let's add in a bar block. I'm going to go for 3, 4, and now I can connect them together like that. And I can then go ahead and add notes. So if I click plus, I get a list of different note lengths. Let's add 3 crotchets. And as you hover over, you can see the arrows up and down. So let's make an arpeggio. To run the program, click play. Okay. So Codetta also has some blocks which are closer to programming concepts. So if I add in an end repeat, I will hear this twice. And there are also other blocks which do procedures. This orange block being one example, which will add 50 BPM to the current tempo every time it's executed. So if I put it in between the two, repeat some more times, the music will speed up. So this combination of music notation and procedural blocks creates a scalable user experience. Novices can easily write long phrases of notes, whereas more sophisticated users can creatively engage with the software's procedural features. Here are some examples made by children aged between 6 and 11, recently gathered as part of work beyond the scope of this paper, but supported by the University of the West of England's Ethics Committee. Any research involving children is difficult to complete for many reasons, which the method presented here aims to avoid. Understandably, there are many ethical considerations to make sure children are safe participating in the study. Educators are also often balancing a challenging workload and cannot take on new projects, particularly those that take lots of time. Research started with the idea for Codetta and a base tool was developed. 2 trainee teachers were recruited. Theoretically, their knowledge from taught degree content and their time on placement would gather valuable insights. 5 iterations were performed in total, triangulating 3 different techniques: the Think Aloud protocol, discourse analysis, and interviews. For the Think Aloud, participants were filmed, following instructions built into Codetta's interface. The Think Aloud was chosen for many reasons. Firstly, participants would externalize their thinking, obtaining a deep insight into their thought processes. There was also no burden on the participants themselves. They only had to follow some instructions one at a time, yet the researcher could replay the information at any point. Furthermore, the environment was controlled, and the participants didn't need to prepare anything else beforehand. After the Think Aloud, the researcher would also ask some questions to probe any theories uncovered by the results of the previous iteration. This meant there was a further opportunity for the researcher to gather opinions on design changes or hypotheses. The transcript of the Think Aloud recording, including body movements and computer interactions, was used as the raw text for discourse analysis. Stowell Plumley and Brian Kinn's paper was used because it focuses on musical interfaces. And it also places the burden on the researcher, providing a low cost in participants' time and resources. The full method is described in their paper, so it will be glossed over for this presentation. All of this resulted in minor increments, refining Codetta's design each iteration. Here I'll highlight some examples, but this is thoroughly documented in the paper. Numerical values were added to the note picker. This is because participants started to refer to note values numerically during the Think Aloud, not feeling comfortable with specialist terminology. Blocks that were too similar in colour were often difficult to distinguish also. Although the category they were in was clear, some were changed to be slightly different. The use of a global tempo block was cumbersome, so was switched to a widget placed at the top of the interface. This made it more obvious that the object changed the whole tempo. Overall, the process successfully yielded useful results from proxy participants. There was no burden placed on practicing educators, and there was no need to undergo a lengthy ethical process as no children were directly involved. The Think Aloud was useful in that it allowed researchers to glean information directly from the student teachers. On the other hand, the discourse analysis was analytically heavy. A researcher writing tutorials, developing software changes, and also transcribing all the interviews doesn't have much time left to do much else. A lightweight alternative, such as Braun and Clark's thematic analysis, may work just as well. Notably, it is recommended that the method is applied in tandem with other evaluative studies to ensure the end user is still heavily involved in the development process. Overall, the method created a strong foundation, preparing Codetta for further study. Ongoing work with Codetta aims to evaluate its real-world use in the classroom and understand children's interaction behaviours in respect to creativity in music composition. Thank you for watching.